I think now we can move to the panel discussion.
Yeah, so if all the speakers from the morning session could rejoin, and we'll set up the virtual chairs on the stage where the panelists would normally sit. So this is a chance for any questions that you didn't get to ask, or new ones that you might want to pose to the entire panel. By the way, this is my daughter, Amelia. I wasn't able to get a babysitter, so she's going to pose some questions as well. Let's check the Q&A. Okay, so we don't have any yet. I wanted to ask one to Rachel that has to do with the difference between Uncanny Valley effects for interactive versus non-interactive settings. And I don't know the right terminology here, but the non-interactive settings I'm thinking of as sort of cinematics, like something where a user is presented a very photorealistic, lifelike avatar, and they get a positive experience because they look very real. The interactive part, the kind of thing that comes to mind is in lower technology settings, for example, an automated phone system, you can have a very realistic voice, but when it misunderstands a voice command on your part, again, I don't know the right terminology here, but when something that appears to be lifelike misunderstands you and tries to respond in a way that sounds human, it can cause a rage response I mean, I've read studies, I'm not saying I do this myself, but it sometimes results in people shouting at the phone system, thinking, you know, I wish it would just be more robotic because then I would at least know what I'm dealing with. So there seems to be some kind of distinction perhaps between the cinematic things and then cases where you're expecting an intelligent response that somehow matches the visual fidelity of the appearance of the avatar. I wonder if you could just speak to that.
Yeah, no, I completely agree with you about that. There hasn't been many studies looking at that actually, where you've got high level of realism and this kind of voice interaction. So that's something we're definitely looking at. But like it's an ethical question as well going forward, I think, because if you are able to produce an avatar that looks this appealing, this realistic, and as you said, and there are lots of tricks that we can do. Even some of my own research, we've looked at ways of making the avatar look more trustworthy and more honest and things like that. So we can like form this avatar that looks extremely realistic to have all the properties that we want for, like, say, for example, selling something, or you know, in a better case for teaching you, you know, more effectively or something like that. But there is an ethical question there because, you know, in a way you're kind of tricking the user, especially when you're talking about therapy sessions and things like that, where maybe the user is an elderly person and they're very trusting towards this character. So yeah, I mean, I've had some conversations with voice researchers, and they're looking, they believe that going towards realism is actually not the way forward. That why do you need it to be like realistic? Why do you need it to replicate a real human's voice? You know what I mean? That what is the need for that? Why, you know? So I guess but then some of our studies have shown that a natural voice is much more appealing. So yeah, there's a trade-off, and I think it'll be important in the future for there to be some sort of indicator on the virtual. So I personally think that the avatar appearance should be such that it gives you an indication of their capability. So straight away you see this avatar in a kind of, you know, and I hope there'll be a standard, and that's something I'm interested to look into as well. In the future, there'll be a standard for the appearance that tells you, okay, this avatar is just going to be able to respond to some queries. This one might have more, you know, might be able to do more, but maybe matching the realism of appearance and the capability of behavior would be something in the future that would be important. Yeah,
I think that's what I was getting at, is something. Thanks for the excellent answer. I think it's about managing expectations, or what kind of cognitive competence is telegraphed by the appearance of the avatar.
Yeah, exactly.
That's really interesting.
Yeah. But I mean, I've often thought about the Uncanny Valley from another point of view as well, of interaction where you're driving the avatar. So you're the avatar, or you're the you know, even in a computer game, in a sense, you're kind of the avatar, but also you can drive it with your own motions, you're mocapping it live. So I'm interested in that as well, and we've done some studies on that to see if, you know, because you're fully in control of this being, even if it is a bit uncanny, maybe your own motions makes you feel less creeped out by that character in a way, because you know
I think if you look, for example, at what Matthias was presenting, where you could have very low bandwidth, high fidelity reproduction on the other end by virtue of hand tracking and so on, that doesn't evoke discomfort. Just from my perspective, it just seems like if you can do that kind of media pipe type analysis, do it and benefit in terms of bit rate. So it's really about that interactive part, and whether you're writing checks that I don't know the right analogy here, but something that ends up frustrating the user. But that's really interesting. Andrew, you want to take the next one?
Sure. So there's a question for Matthias. You mentioned the synthetic data was not quite good enough for training body pose models today. Could you discuss a bit more about the gaps there, whether it's the realistic articulation or the clothing or general appearance?
I think in general, you have to ask yourself, does the synthetic data model the variability that you can find in the real world, right? And I think there with body poses, we really have the challenge that, number one, there's a lot of articulated poses that are not captured in synthetic data. For example, as I mentioned, like fitness setting, dancing, yoga setting. So there are some more unusual poses that go beyond just like standing upright. And then the other one is, of course, folks have all kinds of differences, you know, clothing, appearance, backgrounds across the world. And so synthetic data tends not to be able to model this holistically, right? When you compare that with hands, or when you compare that even with faces, I think the gap there isn't as big. That's why synthetic data alone on hands and faces has worked for us. But on body pose, I think the gap is just too big. And so that's why we're using a parametric approach that we're fitting to the real world data.
Fair enough. I want to follow up a little bit about the compute approaches that you've described regarding doing things on device versus doing it sort of in the browser. How do you think about having a sort of an elastic compute model when you have high bandwidth internet where you can do kind of offline rendering versus having to do computation on device when you have large amount of computation available locally?
Yeah, it's interesting. It depends really on the use case, right? Even if you do inference, if you want to move inference to the cloud, what are the challenges? One challenge that you have is you're not submitting the RGB image, you're submitting a video encoded RGB image. So there is degradation. It's kind of like the server approach will always get the image plus encoding on top of it, right? So that will put it a little bit in a disadvantage. The other thing is that actually I think there isn't a big gap between real-time on server and real-time on device in form of the models that you can run. Because on server, of course, in order to make it cost efficient, right, you will also not run like a giant model because you have a low latency environment. So you still have to operate, you know, within a reasonable latency of, let's say, 50 to 100 milliseconds before it becomes visible in a video streaming session or setting. And so I think that the capacities are actually, you know, relatively similar of the models that you have to use. I think it's interesting if there are models that you really can't run on device. I think it's more of a, depends on the client, right? Is a client really, let's say, $200 Chromebook? Well, you will have not a powerful GPU there, right? And so you can't run the same as you could, for example, run on a high-end MacBook or a desktop computer. And I think in those cases, having a hybrid solution is really appealing, where basically sometimes you will just run rendering as well as inference on the cloud and have a very thin client.
Makes sense. Serge?
I have a question for Kaan, and then after that, we have a question queued up for Rachel again. So several of the presentations talked about Vergence accommodation conflict. And then in the context of projectors in a room, there's also the question of the material of the surface. And for professional projector setups, there are, of course, special screens they would use for viewing a movie or something like that. The materials that are in an office or a home environment are not so great. It could be a sofa, it could be the fabric of a shirt, or highly specular desktop, who knows. So I'm kind of captivated by the way that you're taking all these components out of the head-worn headset. I'm wondering if there's another opportunity when you think about these settings in the enterprise settings or industrial settings, where you are far enough, you have objects that are far enough from the viewer that you're not worried about Vergence accommodation. So I don't know what the number of meters is for that to be relevant. But then, just to draw a loose analogy to this Uncanny Valley effect that we talked about with Rachel, that we could say, let's identify this zone of applicability where the virtual objects are far from the user, far enough that you don't worry about defocus close to your eyes, and that photorealism is not somehow critical to the experience of the user. So it could be something that's kind of educational in nature, as opposed to photorealistic rendering of animals in your bedroom or living room. So this seems to, just from a research perspective, this seems to induce this kind of space where you could say, knowing that we don't need photorealism and that we're able to project on the surfaces that are suboptimal, is that another way of drawing a line and saying, well, if that's the case, you put on essentially a $2 set of glasses with the right kind of diffraction gratings or whatever it is that you put in that, but you need an extremely high frame rate head pose tracker. You need, excellent projector systems. So again, I'm just thinking out loud here, but I love this idea that you could unbundle some of those components. I wonder if you could say more about those, that type of application.
So let me see if I understand your question correctly. I think we talked about 4 different things here. One of them is about Vergence accommodation conflicts and when it is meaningful. And we also talked about, can my work address in the future Vergence accommodation conflict? Can this type of work be useful to resolve Vergence accommodation conflict? And we also talked about photorealism. And when it comes to photorealism, we argued about we don't need that much resolution. Maybe we can keep it simple. And lastly, you also said there are opportunities for computer vision research, let's say, about tracking, because you have to be really, really accurate. I cannot agree more with the last bit of it. Let me start with the Vergence accommodation conflict. Vergence accommodation conflict becomes meaningful at distances that are at your arm's length, let's say. The reason for that is, let's first define what Vergence accommodation conflict is. Vergence accommodation conflict, when you go to a movie theater, everything is projected on a screen, everything is sharp at the screen, but they are showing you things that are different distances with respect to where you stand. There's a mismatch between the focus of the image and the disparity that is present to you. Therefore, your eyes are rotating, but they are not correctly focusing, and this causes a conflict. This kind of conflict is really, really important and can cause lots of trouble in the arm's length, like regions below 1 meter. I think we can start to talk about the importance of vergence accommodation conflict. There is a established, let's say, literature. Specifically, I remember work from Piotr Didik from SIGGRAPH 2016, where he just adjusts the disparity such that actively on the fly, such that he doesn't induce the vergence accommodation conflict, and he keeps things more or less at the focus plane. There are tricks like that that can be arranged to solve vergence accommodation this conflict. And you're very right. If things are far enough, you don't suffer from this problem a lot. You do have this problem still to some degree, but it's not as important as in the arm's length interactions. Can this work address this thing? Maybe yes, in the future. I'm just speculating at this point. If you have the right set of diffractive optical elements in your $2 glasses, let's say, and if this can replay the light field in the way you want it to be played, then yes, why not? You can maybe address multiple depth levels at once. About the photorealism, resolution-wise, I think that we want the resolution mostly at where we are looking at, right? So we want to have the avatar to be looking really, really perfect at the location where I'm looking at, right? So I think there can be a combination of foveated rendering techniques in computer graphics and avatars, and maybe we have this recent work called metameric, the beyond blur metameric visuals, which appeared last year at SIGGRAPH. We show that at peripheral vision, you can place images that are statistically correct, but they are not, when you directly gaze at it, they are not looking correct, right? So one can use such tricks, combine it with avatars, and claim that you don't need that much resolution at places where you don't look at. So there's some things that can be done. About the last bit you just said about tracking, I cannot agree more. This is a huge computer vision problem, and it needs lots of accuracy, lots of speed.
Thanks. Yeah, just to connect it to what Christophe and Hiroshi were talking about, it's very likely that the type of display technology they described will be the path forward for things that are within arm's length. When you look at that compelling example they showed with the spherical object very close to you, that defocus effect is really compelling. And so it could be, and this is probably the nature of your research, the way you're breaking down these different areas of applicability, but it seems like there's a zone beyond arm's length where a different kind of technology and cost profile could kick in, just with really, really different kinds of applications. Okay, Andrew, do you want to pass along Sophia's question? You're muted.
That's right. Sorry about that. This one's for Rachel. As we sort of interact with digital content more and more, how do you think the concept and the sensibility of the Uncanny Valley evolves? Are we becoming sort of more agnostic to it and comfortable with interacting with digital beings?
Yeah, I think so. I mean, I think we just like the more we get used to looking at virtual characters, I think it actually goes away a little bit. But it's very complicated, the Uncanny Valley, in the sense that it's not just one thing like where they're a bit more realistic. Now we feel it's very multi-layered, and that's what we've found in our experiments, that it's not just but I do think exposure definitely has an effect. Like long-term exposure, I think I would say would reduce the effect a bit, but it could also heighten the effect. If you look back at some visual effects that we thought were highly realistic 5-10 years ago, now you kind of go, I can kind of see them now. So I think there's no definite answer to that, but I do think a lot of the photorealistic virtual characters that are out there now are, I don't know if you'll say they're beyond the Uncanny Valley in the sense that they definitely look real, but I think they're beyond the point of being creepy. Like I don't think, unless they have maybe behaviors or animations, the actual characters and the movement themselves. Personally, I don't think. But again, I look at virtual humans all day long, so that could be that could be one of the issues that I've overexposed. But yeah, definitely, I think exposure changes the relationship with the Uncanny Valley, but how much it changes it, I don't know that for sure. Yeah, or what effects it has.
Yeah, an interesting parallel is that because of, you know, a much larger exposure to online communication these days, we do experience seeing and hearing each other in a less than natural way, right? People become more pixelated, the audio gets very digital. So we do see each other in this sort of avatarish way. And I wonder how that affects our perception of digital beings as well.
Yeah, I think so. I mean, it's very the way we've been interacting, I guess, for the last year or so. It's quite unnatural in the sense that you're looking at your own face all the time as well. I think that's, for me, that's one of the things that's quite strange, and that's what pushed us to looking at AR filters and perception of self perception and how that affects your interactions with other people online. You know, so if you put some augmented reality filters on your face, for example, it is kind of like embodying an avatar in a way. And we're very interested to see how that, because you're looking at yourself as well as other people when you're interacting now, you don't do that in normal life, you know. Does that actually give you this Proteus effect? I don't know, the Proteus effect is an effect in virtual reality where you take on the characteristics of your avatar. So there's been experiments done where, like, if you're a hero, a superhero, that you start acting a bit kinder afterwards, versus if you're a villain in a, you know, if you're embodied in a villain, that kind of thing. So this Proteus effect, we think can happen in AR as well. So where you've got a filter on, and some of the filters nowadays, you know, we've seen some of the amazing tracking, Google and everything. They can be very realistic. Like you can, you know, change the size of your eyes to make your eyes look more honest, or something like that. And it's interesting to see if we take on this avatar related Proteus effect in AR as well. Yeah, so yeah, definitely.
Great. Serge, do you want to take one from Fernando?
Sorry, I just need to find the unmute button. Sorry, you said, should I take one what?
From Fernando that he posted on Slack.
Oh, yes. So this is a follow-up for Matthias. So there's an ICCV 2021 paper from Microsoft that shows that in tasks like key point detection and segmentation, synthetic data worked well. Is that different because it's 3D? This is a two-part question. Let me just stop at that part. Or if you just, Matthias just wanted to expand on the pros and cons of or the limitations of the synthetic data in your setting for 2D or 3D, and then I'll say the second part.
I think the Microsoft ICCV work, we're talking about synthetic faces, right? Was it recently released, or was it for synthetic humans?
I'm sorry, was that a question for Fernando?
Yes. Very cute.
The ICCV paper addressed mostly faces in the context of key point detection and segmentation, but was one of the first papers that showed that without any domain transfer, you know, because now we have the capability of synthesize hyper-realistic faces. Synthetic data was enough to train models with and being able to work well in realistic data. And this was a little bit to follow up a little bit with the question that you already answered from Matt, but yeah. So yeah, the question is if you think we don't have enough the capability of synthesize humans in clothing and render well enough as we can do in faces, And that's why we are not able to use these for the key point, body key point estimation or other tasks for human sensing that you show.
Yeah, so as I mentioned before, right, I really see that the domain gap primarily exists around body pose, just because I do think it's a more challenging domain and problem that you have to tackle. I agree that synthetic data for hands and faces is often actually sufficient, where you don't need some form of parametric model or lab setup in order to scan things. I think one very important detail we shouldn't forget is when we are building models that need to work in products or need to work on third-party developer APIs, we really need to ensure that it works for everyone, right? And so it's actually difficult to do this evaluation or guarantee with synthetic data alone. So this is a concept of ML fairness, right? You do want to make sure that the ML model performs well on, for everyone, regardless of gender, skin tone, or even geographic locality, because you can have these correlations, that particular clothing, for example, correlates with some locality, and so your model suddenly is worse there. And so in order to do, I would say, a pretty good evaluation around this, I think you do need to basically collect a large data set of real world data that covers, gender, skin tone, as well as geographic location. You want to make sure that it's actually distributed fairly uniform across those categories. And so then you can basically ensure that your model has high quality across those different subpopulations. And I think for that, real world data is absolutely critical.
Well, I'd like to follow up quickly with a question around other type of data. So with synthetic data being a little bit of a limiting factor today, we still mostly rely on manually collected and annotated data. Matthias, can you talk a little bit about this sort of human in the loop, auto labeling, auto retraining, maybe self-supervised learning pipeline?
Yeah, we're basically following, or I would say I'm a fan of how Andrew Ng is phrasing it, right? That a lot of the investment has to go into a data pipeline. You don't want to collect data once, annotate it once, and then basically keep it constant, train your model, and just iterate over a model in form of like a benchmark setting. What you really need to do is you need to evaluate the quality in the product use case or in the user use case, right? Things that you might have not had in the data to begin with, for example, in the meat segmentation use case, right? Suddenly you have folks that sit in gamer chairs, or they are picking up objects. And so that stuff might be just missing in your data. And so your segmentation model is just doing a poor job around it. Or there could be particular hairstyles that we're missing. And so what you really need to do is you need to observe the quality of the model in some kind of like trial phase in a real world setting. You need to know when it's failing. Then you need to kind of like have a path to collect the data where it's failing, and then basically annotate that, add it to the data set and iterate. So it's really, I would say, a month-long process to come up with the right representative data and high quality annotations. Another challenge that we often see is that when you annotate something for the first time, segmentation is kind of simple, like a binary segmentation. You draft up some rules, you say that object should be part of it or not. But then there could be settings like annotating face meshes, right? Where does, for example, the lip start compared to or in contrast to the face? So what we often do is actually we realize as we look at the final product experience, we need to refine the annotation rules. We need to change a little bit the point locations. And so the point that I want to stress here is it's not so much about state-of-the-art performance according to a benchmark data set where you can define it once and then you get to the metric that you have or not, but it's really about the final product experience. And often that will change the metric, the annotation, as well as the data that you need.
Very good, thanks. Are there any other questions from the general audience or the panelists at this point? Cool. So with that, maybe we'll conclude the panel discussion. And I think let's virtually thank all the speakers. Thanks for attending. It was great to have you on board. And right now we're going to take a short break for lunch and return at 1 o'clock. Thanks, everybody.
Yeah, thank you to all the speakers.